Good afternoon, and hello everyone. Thank you for joining us today for the August 2016 Ona Report, Broom Sedge Management in Bahiagrass, Pastures, and Ongoing Study. My name is Brent Sellers. I'm an Associate Professor and the Associate Center Director of the UF IFAS Range Cattle Research and Education Center, specializing in pasture and rangeland weed management. At the conclusion of today's presentation, there will be time for questions. At that time, you'll be able to type your question into the GoToWebinar's questions panel, or you're welcome to send us an email or call anytime, and I'll have that contact information at the end of the presentation. All right. So broom sedge, I think a lot of people like to confuse broom sedge with actual sedges, but broom sedge is a grass species. There are about 18 different species present in the state, and they are clump-forming perennials. That's what tufted means on the first bullet. And they live approximately 3 to 5 years on average, some probably a little bit longer, some a little bit less. But they are extremely evident this time of year as they're starting to send up their flowering shoots. Over the years, we've heard a lot of people state if you just lime your pastures, the broom sedge populations will go away. But what we've found over the last several years, that pH may not be the only reason that broom sedge might be infesting pastures. And you got to consider the amount of species that we have in the state, that different species may react differently to the pH of a particular pasture. So on the table that's here on this slide, we went out and collected soil samples in broom sedge infested pastures about 3 or 4 years ago now. And we were in Hardy, Polk County, Okeechobee, Highlands, Manatee. It's Hardy is again here at the center, and then Glades and DeSoto counties. And you can see that the pH ranged all over the board, anywhere from 4.3, 4.1 in Highlands, all the way up to 7.8 in DeSoto. So what was interesting about these sites is that there's almost a different species at every location. So at Ona, we had purple blue stem, which is what we're going to talk about today. And then at the other sites, there'd be a mixture of what we would call the broom sedge blue stem, which most people, I think, consider broom sedge. It's the one that turns straw yellow here in about a month. It's the first one to really change colors. And then other species like bushy blue stem was present at the DeSoto location. Again, we'll talk about that one as well. What was pretty consistent across all these sites as well is all of them were very low in macronutrients as well as micronutrients, and I just pulled the P and the copper and zinc out of those soil tests, and basically everything was very medium, or very low. The only site that was different from the rest of them was the Polk County location where I have the 2 asterisks, and that pH was around 6.0, and it had high phosphorus concentrations as well as copper and zinc. And what was a little bit peculiar and what got me going on the project that I'm talking about today is that the broom sedge population was declining in that pasture according to the rancher. So that was pretty exciting. That kind of gave us an idea that it might be not only pH related in some cases, but also fertility related. But that's not to say that pH does not have an impact at all. At purple blue stem, this was here at Ona. We actually took soil from the field and amended it with lime to get different levels of soil pH, and then we transplanted purple blue stem seedlings into these pots and measured their growth and height for 9 weeks. And basically what you see in the blue bar is we have taller plants where the pH was more acidic, but as we made that soil more alkaline and increased the pH, the height wasn't nearly as high as the low pH soil. So pH does have an impact on some species, but probably not all of them. So, like I said a couple slides ago, I mean, the Polk County location gave me some circumstantial evidence that either macro or micronutrients might be influencing the broom sedge populations in the pastures. So my real question is it the phosphorus that has a role, or is it some other macronutrient, or is it all three, N, P, and K, that we have to have? Or does copper have a role? And the reason I brought that into the picture was another site that I didn't talk about earlier. They had applied some biosolids from a citrus processing plant lagoon, and wherever they had spread that biosolids, that had a minimal amount of copper in it, but that's about all that was in that. And they had no broom sedge in that side of the pasture where that had been spread. So I thought perhaps there is a role of copper, or is there something else that we're not even seeing? So that kind of led us into our experiments. We had 3 locations, one here at the Research Center, one in Arcadia, and one in St. Cloud. Both the Ona and Arcadia locations were started in 2012. St. Cloud was set up in 2012, but we didn't start the experiment until 2013. And all these sites had annual applications of 500 pounds at 10-5-10 fertilizer and 25 pounds of 503G micronutrient mix. And we amended the soil when necessary. We took broom sedge counts annually at the beginning of the experiment before we started applying any fertilizer, and we used a georeference box 4 within each plot, so we could go back to the exact location and count the number of broom sedge plants that were in that area over time. We also pulled soil and tissue samples in the fall of each year, but we also pulled soil samples prior to the beginning of the experiment. So this is what our soil characteristics looked like before applying any fertilizer whatsoever, as well as the species that was present at each location. At Arcadia, and actually I have a typo, that should be a pH of 7.8, and very low P and K values and hardly any micronutrients. And that was the bushy bluestem. This is the one we typically see along roadsides because the soil pH is also so high on roadsides as well. And we had about 5 plants per square meter at that location. At Ona, our soil pH, our initial soil pH was 4.3. Again, very low concentrations of macro and micronutrients. And we had purple bluestem here at about 3 plants per square meter. And at St. Cloud, the pH was 5.5, right on target for Bahiagrass. And again, very low macro and micronutrients, but this different species of broom sedge bluestem, as well as a couple others. And we had about 4 plants per square meter at that location. So this was a plot layout. I showed this a couple slides ago, but I wanted to explain this a little bit further. So, because it gets a little bit confusing because each location was a little bit different with how we set up our treatment structure. So at Ona, we had a 3-way factorial of lime, either lime or no lime, and with and without NP and K, and with and without micronutrients. At Arcadia, since our pH was so high, we were actually applying sulfur in place of lime at 100 pounds per acre annually. So lime application at Ona was only in 2012. In Arcadia, we applied annually 100 pounds of sulfur per acre. And at St. Cloud, we have not applied a liming agent or sulfur agent at all because it was at the optimum pH at the beginning of the experiment. So I'm flying through this pretty quickly, but the results at Arcadia, basically we saw a response from NP and K fertilizer as early as 2014. And this is the only location where we saw it as early as 2 years after we started applying fertilizers. We had no response from sulfur or micronutrients whatsoever. But in 2014, in the blue bars, this is without any fertilizer. we had about 68% of our initial population, so this is plant density as percent of initial. And then with fertilizer, we were around 45% of our initial population. So even without fertilizer at this location, we're dropping our broom sedge population, and I believe what's going on in that case is that producer is actually mowing those pastures at least 2 times a year. So I think mowing might have some impact on this species as well. When you got out into 2015, we actually went down to 60% of the initial population without fertilizer, and then just over 30% with the fertilizer in 2015. And then in 2016, we saw a slight bump in our untreated plots without fertilizer, and then also a very slight bump, up around 35%, still probably pretty even with measurement errors in the field. So at this location, we're pretty excited that we are seeing a response as early as 2 years, and we seem to be holding that with annual applications of fertilizer. I will say at this location, this is probably the most sparse Bahiagrass stand that we had because of the high pH. The Bahiagrass is slowly flowing back in, but our pH is still fairly high, and I will show that in a few minutes. At Ona, it took about 3 years before we saw a response, and we've only seen a response from liming in 2015 and 2016, and then finally in 2016 we did see a response from fertilization as well. But in 2015 with liming, we had about 85–90% of the initial plant densities without lime. But when we did lime plots, we had around 50% of our initial densities. So we're declining it over time. But remember, these plants are 3 to 5 year lived plants, so it's going to take time for us to get rid of them completely. Going to 2016, we actually have more plants in plots that weren't limed than we did at the beginning of the experiment, which is something that I actually expected to see, but we're still holding just under 50% of the original population in plots that were limed in 2016. When you look at fertilizer, again, I said it took us until 2016 before we started seeing a significant effect from the fertilizer. Again, nearly 115% of the initial population without fertilizer. We fertilize those plots annually. We do see a drop, consistent drop to around 45–50% of our initial population, but it takes a while to get there. All right, so at the St. Cloud location, unfortunately, we have not seen anything similar to what we've seen at the other 2 locations. So we're going to continue to look at those plots, but we're not seeing anything consistently happen at the St. Cloud location. As far as soil pH goes, even though we are applying elemental sulfur annually at 100 pounds per acre, which probably is not enough, we're not seeing any change in the soil pH across the board. At Ona, we are seeing an increase in soil pH from 4.3 to 4.9, but this really indicates that we need to lime these plots again. And this was only in the lime plots. In the unlimed plots, they've held steady at 4.3. And at St. Cloud, our pH has dropped from 5.5 to 5.0, which is going to cause us to lime it next year. Soil macronutrients, no major changes in phosphorus concentrations when they're sampled at 4 to 6 inches. We did not sample any deeper than that. And this is after fertilization. Remember, these samples were pulled in the fall of every year. So in Arcadia, they've held steady around 48 pounds per acre in all years. In Ona, they declined, phosphorus concentration has declined over time, 38 pounds to 17 pounds, probably more due to water movement in the soil profile than anything. And then at the St. Cloud location, we're also decreasing phosphorus even across the board. For potassium, we've only seen differences in the Arcadia location. In each 2013 through 2015, we tend to have more potassium in the fertilized plots versus the unfertilized plots really doesn't shock me all that much. I'm not sure why we're not seeing an increase in the other locations similar to this. But like the phosphorus at Ona, we're seeing a decline in the potassium from 2012 to 2015, but a slight increase in potassium at St. Cloud. For tissue P concentrations, and this is a little bit interesting to me, when we look across the different sites we're looking at Arcadia, without and with NP and K fertilizer, we're always at or below the critical limit for phosphorus in Bahiagrass. At the Ona location, we were hardly ever below or at the limit until we got to 2014 without any fertilizer, and that kind of held true without fertilizer at the Ona location in 2015. But we did see a slight bump from 2014 to 2015 in the tissue P at Ona. And the same thing holds true at St. Cloud as we saw in Arcadia for the most part. We had a slight bump here with the NPK in 2013, but by and far usually at or below the critical tissue limit for P. All right, so I wanted to end today with a couple slides on using a wiper, and we looked at this a couple years ago, using a wiper to control broom sedge. We had several paddocks out here at the research center that they wanted to use for a grazing trial, and we wanted to get rid of the broom sedge that was in those plots. And this was our only option, really, unless somebody was going to go out and spot spray about 1,000 plants. So we decided to go purchase a weed wiper for the research center, and we wiped a 10% glyphosate solution in 2 directions. But as my colleague Jay Farrell says quite a bit, this using a wiper thing is kind of an art, and it takes a little bit of practice to get this to work effectively. But we did do this in late August, early September in 2014, and this is a picture about 2 weeks after these plants were wiped. So you can see they're turning yellow, brown. They are going backwards, and these were wiped in 2 directions. And these paddocks were mowed about 2 weeks after, so about a day after this picture was taken, these paddocks were mowed. And I was like, well, all bets are off. This probably isn't going to work very well. But we went back a year later, and we controlled about 60–70% of that population. We went ahead last August, September, and wiped again, same concentration. And this picture shows what these pastures looked like 2 years, about 2 years. We took this picture in June this year. So you can see how much cleaner this pasture is compared to 2 years before. So we're pretty excited about that. I think that's really a great option for our producers that have broom sedge that really have no alternative, since we have no selective herbicides for broom sedge management in Bahiagrass at all. So in summary, basically where soil pH is off, broom sedge is beginning to respond, but this is going to take time. Remember, I said these plants live for about 3 to 5 years, so it's going to take us a while to build up our soil and basically let those plants die, and hoping that our Bahiagrass will fill in and be more competitive to keep more broom sedge from germinating and becoming established. But wiping is an alternative. I think is a viable alternative, about really our only option we have. But I think our next steps is trying to figure out what macronutrient is doing the work. Is there an optimal glyphosate concentration for wiping? We use 10%. Can we go down to 5%, save a little bit of money that way? And another thing I'm really interested in is using a roller chopper, kind of break up any clumps of broom sedge that are there and fertilize those pastures, try to get the Bahiagrass more competitive than the broom sedge over time. So that is the end of this presentation, but I wanted to tell you about the next webinar by Chris Pravat. That'll be September 15th at noon. And he's always creative in his titles. Should I buy stocker calves this fall or a fishing license? And that will be Chris Pravat's presentation. And my contact information is there. If you need to contact me later. Since Chris is talking about getting a fishing license, I'm taking my son and going fishing this afternoon. So that should be it. If you have any questions, feel free to type them in the panel right now. I can get it to work.
See if they have any questions.
Does anybody have any questions out here?
I do.
Okay.
The pastures that you wiped, were they fertilized as well or not?
Okay, Dr. Silvera is asking if the questions that were wiped, if they were fertilized as well or not. And I'm not sure if they were or not. Dr. Arthington used those pastures. Did you fertilize them?
What year was that?
We started in 2014. I don't think they were fertilized in 2014, but I think they might have been in 2015.
I think so, yeah.
Yeah. So yeah, they weren't fertilized yet. Okay, a question from online says, what if we mow before wiping? Would it improve the efficacy of the wiping? And basically, you have to get your broom sedge taller than your desirable forage. Because if you go back to the pictures that I showed, we were basically wiping it on the flowering stems, not so much leaf material. That was another thing I really didn't think it was going to work that well. But it did. So as long as your broom sedge is above your desirable forage, I don't think mowing really adds any benefit to it. And then the next question is, what's the critical limit of P in tissue? And it's 0.15%. 0.15% for Bahiagrass. Okay. Are there any other questions? Okay, is there a best time of year to use the wiper? And also a good question. I don't think it really matters what time of year, as long as these plants are actively growing and as long as they're growing above your desirable forage, it should be sufficient. And next question is, what will the chopping accomplish? And basically my thinking there is to break up the broom sedge plants some. I haven't thought about timing too much at this point, but one of my thoughts was, and I've seen this with smut grass in the past as well, if you're able to chop in the dry part of the year, you actually end up desiccating these clump grasses where the Bahiagrass doesn't desiccate as much. And that's kind of where I'm thinking with the chopping at this point in time. Any other questions out here? Okay. Well, again, I thank everyone for attending today, and be sure to come back in on September 15th for Chris Pravat's next webinar.